welcome to the derivative of a polynomial. So just recall from the previous video, we have that the derivative of a constant is 0. We had that the derivative of x to the nth power was n x to the n minus 1. Again, pull the power out front and then drop the exponent by 1. We had that the derivative of a scalar times a function was just the scalar times that derivative of the function. And then also we have that the derivative of f of x plus g of x, or plus or minus g of x, was just f prime of x plus or minus g prime of x. And again, we discussed the fact that with all of these together, we can take the derivative of any polynomial. So let's go ahead and just do some practice. So first up, let's find the derivative of f of x equals 2x squared minus 5x plus 6. So we have f prime of x is equal to, we can go ahead and separate this. It's the derivative of 2x squared minus the derivative of 5x plus the derivative of 6. So that's using the sum and difference rule. So this was our rule 4. I'm going to label these quickly. So this is rule 1, 2, 3, and 4. And here we just used rule 4. Then next up, we can go ahead and pull out any scalars. So we can take the 2 out front, and then we're taking the derivative of x squared. We can take the 5 out front, and we are simply taking the derivative of x. And then we still have our constant function. So this was using rule 3. From here, we can use our power rule. So the derivative of x squared is 2 times x to the first power. The derivative of x, we would pull out a 1 and then do x to the 0th power. So I'm going to put an x to the 0th power briefly. And then the derivative of 6, that's a constant function, is just 0. So here we are using rules 2 and 1. So what we wind up getting is simply 4x minus 5. And now let's go ahead and take the derivative of g of x is equal to negative 6x cubed minus 4x squared plus 3x minus 2. So once again, we can break this up with our derivative rules. So we have g prime of x is equal to the derivative of negative 6x cubed minus the derivative of 4x squared plus the derivative of 3x minus the derivative of 2. So that again was using rule 4. Then from here we can go ahead and pull out our scalars. We have a negative 6 times the derivative of x cubed minus 4 times the derivative of x squared plus 3 times the derivative of x minus the derivative of 2. Again, that was pulling out our scalars. That was our rule 3. From here, we have our power rule. So this is -6 times 3x squared. Pulled out the 3, dropped that power by 1. -4 times x squared will now go to 2x to the first power, or just 2x. Plus 3 times the derivative of x is just 1. Right? X to the 0th is 1. And then derivative of 2 is 0. Constant function has derivative of 0. So this was rules again, 2 and 1. And we wind up with -18x squared minus 8x plus 3. Now, when you do these yourself, as you get more comfortable with them, you do not need to write out all of these steps. So I typically would jump straight to this third line. So as you get more comfortable, you can jump straight to this line. And then some of you will probably just jump straight to the end. I just recommend at least showing the intermediary line so that I can see you have the work, that you know what you were supposed to be doing in case you make a mistake with your multiplication. All right, one more example. Let's go ahead and find the derivative of h of x equals 3x to the 15th minus 2x to the 4th plus 7x. So once again, h prime of x is equal to, we can separate this out. We have the derivative of 3x to the 15th minus the derivative of 2x to the 4th plus the derivative of 7x. Now we can go ahead and pull out those scalars. This is 3 times the derivative of x to the 15th minus 2 times the derivative of x to the 4th plus 7 times the derivative of x. Again, this becomes 3 times, pull the power out front, 15x to the 14th, if we drop by 1. And we have minus 2 times 4x to the 3rd power. Again, pull the 4 out front, drop the power to 3. And then this is just plus 7 times 1. Or 45x to the 14th minus 8x cubed plus 7. Once again, if we had to do this with a limit definition, x to the 15th, we would have had to do it x plus h, that whole thing raised to the 15th, which would not have been fun. So you can see these derivative rules let us work our way through much, much faster and with much less risk of making an algebra error.